If there's a compromise in the quality of your red blood cells, you're going to lower your ability to deliver that oxygen, okay? But if that fuel can't be delivered, well, then we kind of have a problem, right? We have interference. If you're not delivering oxygen very well to your brain, you're not delivering oxygen very well to your muscles, and if you're a long-distance track athlete, your muscles need energy. Well, if there's a compromise in that system, you increase the risk of getting injured, of course. But if you're scoring, in second and third place at races, once in a while you get first place, who's to say that if you improve the oxygen delivery that you wouldn't be first place more often, that you wouldn't perform at a higher level? So remember, you don't know what you don't know. So in this case, we're dealing with preventing injuries, and everybody knows, everyone who has a teenage young athlete knows that injuries can really compromise a student's career. Reducing the risk for injury, improving performance, and of course, when it comes to our grades, when it comes to our performance in the classroom, your brain demands so much energy. Why would you want compromised red blood cells? So what happens is these red blood cells not only are not delivering their product, their oxygen, very well. We can see different characteristics of the red blood cell in the blood test, like the size of the red blood cell. We call that MCV, but the size of the red blood cell matters. If it's a big red blood cell, it's not going to deliver oxygen very well. That's usually related to vitamin B12. If it's a tiny red blood cell, it's not going to deliver oxygen very well. That's usually related to iron levels. So we can learn a lot by looking at these blood tests.